In this video, I am going to discuss about some of the questions asked from DC motor in GATE examination. So let us see first question. In this question, the question is that neglecting all losses that develop torque T of a DC separately excited motor operating under constant terminal voltage is related to its output power P as n. Which relation is correct? This question is asking if losses are neglected and motor is separately excited motor. So for separately excited motor, means excitation is like this. Excitation is done from outside, and this is a motor, DC motor. So this excitation is outside, so here flux is constant. Constant flux is provided here if armature reaction is neglected. It is saying in machine that developed torque T of a DC, neglecting all losses are neglected. So if this is constant, if field excitation is kept constant for constant excitation. Now the relation, as we know, torque is proportional to flux multiplied by armature current. Here flux is constant, so torque is proportional to Ia armature, because this is constant. Okay. So now what we do? So but power, we know power equal to voltage multiplied by current. So here voltage is also a constant, V is constant, so power is proportional to Ia and Ia is proportional to torque. So your relation is power is proportional to torque or torque is proportional, so B part is correct option. Next, this question is about this is also GATE question. A cumulative compound long shunt motor is driving a load at rated torque and rated speed. If the series field is shunted by a resistance equal to the resistance of the series field, means whatever series field is here, now it is shunted, same shunted by here. Although when it is shunted, what will happen? It is shunted and it is shown here. Now question asking which one is the correct option. The armature current will increase in this motor. It is saying that cumulative round long shunt motor driving a load at rated torque and rated speed. Torque is rated and speed is also rated. Now resistance is diverted, means when current was going this side, some shunt part is included here and keeping the torque constant. This is the main clue is here. Torque is constant. So torque is proportional to phi into Ia. When this shunt field is brought here, what will happen? This series flux will decrease, because this flux, early suppose it is phi. Now some part, half of part will go here, because same amount it is taken. So half will be here and half will be here. So this flux, what happens? This flux decreases. So to keep this torque constant, I current has to increase. So the armature current increases. This option will be the correct. Armature current increases, motor speed decreases, armature current decreases. So part 1 will be the correct choice. Now another question is a 4-pole dynamo with wave wound. 4-pole dynamo with wave wound. Wave wound means parallel path will be parallel path A equal to 2. It is fixed. It is wave. 4 P equal to 4, it is given. It is direct numerical question. Wound armature has 51 slots. 51 slots. The induced EMF is E equal to 357 volt. Speed is 8500. Flux code, direct formula, E equal to 5ZNP by 60A equal to 357. This flux is not known. Z number of conductors. How many conductors? 51 slots, 20 conductors. So 51 slot multiplied by 20 means in one slot 20 conductor is there. So 51 slots are there. So question given 21 conductor in each slot means one slot has 21 conductor. How many slots? 51 slots. So conductor will be multiplied by speed in RPM 8500 multiplied by poles are 4 and parallel divided by 60 into parallel path is 2 because it is wave winding. So it is equal to 357. You just need to solve it and you will get the correct value, that is 1.23 milliweber. You will get this value of phi. So 1.23 milliweber. So your answer is B is correct answer. Now you come on this question. This is very interesting question asked in the GATE examination. Although all questions in GATE examinations are very interesting question, but you come on this point. This question is quite informative question. So this question is giving this question. I am going to explain you. 4-pole lap wound. 4-pole motor is there. Generator is DC generator has developed power P watt and the output voltage is E volt. Two adjacent brushes of the machine are removed as they are worn out. Two adjacent brushes. You see this diagram I am going to draw. It is like that. Here I am going just drawing a rough diagram. So this is your motor like this. Here I am going to put one brush. Here I am going to put another brush. Here I am going to put another brush. Then these are the 4 brushes which I have drawn here. Now see here what is happening here. 4 pole machines DC generator is given here and 4 parallel paths are there because it is lap winding. In lap winding, number of poles is equal to number of parallel paths. Number of pole is 4, so parallel path will be 4. So 1, 2, 3, 4 parallel paths are given here. 2 adjacent brushes. This I have taken these 2 brushes are burn out and it has to be removed for the replacement. Now what will happen? So now if the machine operates with the remaining brushes, the developed voltage and power can be obtained from the machine. If it is happen, how much current, how much power you will get output and how much voltage you will get output, that is we have to find out in this question. So let us see here it is a generator. So I assume that IA current is going outside and here IA current is going inside. So this IA current because 4 paths are there, so IA by 2 goes here and the remaining IA by 2 goes here. When this IA by 2 current come here, it has also 2 parts. So half will go here, half will go here. IA by 4 will go here, IA by 4 will go here. From this IA by 2, IA by 4 will go here, IA by 4 go here. So these 2 again meet here and then IA by 2 will come. So whatever IA by 2 will come here and IA by 2 will come here. So this will meet and IA current will be going outside. So this is our current division rule as per the Kirchhoff current law. Now these 2 points are broken. What will happen then? Then only this IA by 4 current will go from here. So now induced a voltage from here to here, it will again remain the same. Voltage does not change, but current changes, new current will be equal to IA1 equal to IA by 4. So your power relation will be equal to new power will be P1 equal to E voltage multiplied by new current IA by 4. So EA multiplied by IA volt divided by 4. So this is your P. So new power will be P by 4 and voltage will remain constant like this. So I am going to discuss another very important question. That a question is that a 240 volt DC shunt motor draws a 15 ampere while supplying the rated load at a speed of 80 radian per second. The armature resistance is 0.5 ohm and the field winding resistance is 80 ohm. The net voltage across the armature resistance at the time of plugging. Means what will be the armature voltage when the motor is plugging. Plugging means the connection is reversed. Means positive connection here, negative is here. So it will be reversed. So negative will be here and positive will be here. So this is the now question asking what will be the voltage during the, what is the net voltage across the armature resistance net voltage when the machine is plugging. So let us see how we can solve this problem. This problem is also very interesting problem. So you see here what is happening. So in the case as the machine is running as so you see in this problem the input current is 15 ampere and voltage is how much here, 240 volt is here. So you can find here the field current. The field current will be 240 divided by 80. It is 80, not 80. So it will be 3 ampere. So 3 ampere current goes here, 15 ampere is coming here. So remaining current will go here, 12 ampere current will go here. 0.5 volt ohm is the resistance of the armature. So 12 multiplied by 0.5 means 6 volt drop will be here at the armature terminal. So 6 volt will be drop here. How much voltage we are giving? We are giving here 240. 6 volt will be drop here. So remaining volt 240 minus 6 equal to 234 volt you will get across the armature. Now what is happening? This armature terminal is being reversed. When this terminal is being reversed, now it is asked. So here you see what is happening. So now connection is reversed. So here 234 volt will be there, but the negative will be here, positive will be here. Now here voltage is demanded. What is the voltage here? So you can just apply by the Kirchhoff voltage law. So plus to minus, so voltage will be plus VR. Then minus to plus, so it will be negative 234 volt. Again you are moving minus, so it will be minus 240 equal to 0. So this give you VR equal to, just you add this 474 volt. So your first part is the D part is the correct option. Now in second part it is asking that how much external resistance you will add in the armature circuit here so that the current limits to 1.25% of its rated value. How much is the rated value? Its rated value is 12 ampere. So it becomes 125%. So multiplied by 125%. So this and it will be voltage. How much voltage is here? So here voltage is across the armature is just we have calculated. It is 474 volt divided by armature resistance already 0.5 plus external resistance R. After solving this you will get the value of R equal to 31.1 ohm. So this is 31.1 ohm. This option is your correct answer. So this question is a very good question asked for all the concept. You will be able to understand whatever till now I have discussed. So to find any kind of voltage between any circuit, I will give you one link here. You can go through that link and you can find the voltage between any two point of a circuit of to get the voltage between any 2 points. Like suppose that if you have like this voltage, I'm just drawing here, and one voltage source is here, another voltage source with some resistance is here, and suppose that the question asking what is the potential difference between A and B. this type of I will give you link. You can find the voltage difference between any 2 points of the circuit.